In a distant future, 1 trillion years from now, the last remnants of a once great civilization stand at the precipice of eternal darkness. Their glory days are but distant memories, for they were a race of engineers who once spanned entire star systems, dismantling planets and asteroids to construct a colossal interstellar empire. Yet, in the twilight of their existence, all has crumbled to dust. The universe itself is in the throes of decay, with the last stars flickering out like fading candles over countless millennia. The once vibrant sky has given way to an unending night, an aging universe gripped by desolation and entropy. Amidst this profound darkness, they wait, their hope dwindling, knowing that the end is inevitable. Long before it came, they recognized the universe's path toward decline. In a desperate bid to outlast eternity, they scoured the cosmos for a final refuge, embarking on one last monumental feat of engineering. Around a solitary lost black hole, they built a new home. They used the remnants of worlds and asteroids to construct an impenetrable shell that would enclose them within the cold embrace of the void. Inside this fragile cocoon, barely resisting the gravitational pull of their savior, they eked out their meager existence. The fading light of dying stars bathed their final sanctuary while they harnessed the energy of the swirling black hole to sustain themselves. But the black hole offered them more than just power. It bestowed upon them the most precious gift of all: time. No one remembered the name of the great scientist who first unlocked the secrets of time's nature. Still, the astro-engineers understood that time was not a uniform concept across the cosmos. Within the immense gravity of the black hole, time flowed at a sluggish pace, while outside entire eons sped by in mere moments. Thus, the last remnants of this once mighty civilization watched the future unfold before them. Yet they knew this was but a delay, not a reprieve. The shroud of darkness would inevitably engulf them, forever sealing their fate. This tale, though speculative, draws its foundation from a scientific idea that reshaped the universe. Over a century had passed since Einstein's theory of relativity revolutionized our understanding of space and time. But questions lingered, profound and tantalizing. What is space truly composed of? Does time exist as an absolute, and could the quest for their ultimate nature lead to a sudden revelation? As we delve deeper, the very fabric of space and time becomes increasingly elusive, inviting us to embark on a cinematic journey into the unknown. In the quiet expanse of the lonely world, where time held its breath and the cosmos danced to an enigmatic rhythm, a secret pulse reverberated. This was the beating heart, a mysterious force that had woven itself into the very fabric of the universe, warping space and reality around it. The civilization that called this world home had embarked on a relentless quest to stave off the inevitable, to defy the inevitable march of time. They dared the inexorable march of time. They dared the universe to challenge them, bending reality to their will, but they could not break free from the shackles of destiny. Hidden behind the cosmic tapestry, obscured by the veils of space and time, lay an idea so profound, so elegant that its eventual revelation would leave humanity wondering in awe. Whether in a decade, a century, or a millennium, they would gather and whisper, "Could it truly have been any other way? How could we have remained so blind for so long?" The enigma of space lingered like a cosmic riddle. What is space? A question seemingly simple yet profoundly elusive. Like children pointing to directions, we once labeled our world with notions of up and down, left and right, front and back. a three-dimensional playground for exploration, or so we thought. But what lay beneath this facade? What defined the stage upon which our existence unfolded? Such musings were the playground of ancient philosophers. Back in the 4th century BC, Plato, in his wisdom, called space the nurse of becoming, an ethereal medium in which all things existed, devoid of inherent qualities. His disciple, Aristotle, agreed that an empty void was an impossibility. Yet, it wasn't until more than 2 millennia later that a true understanding of space would start to emerge. The 17th century ushered in a scientific revolution, crystallizing the universe's processes into laws and equations. A transformation from myth and folklore to the eloquent language of mathematics was underway. Amidst this metamorphosis, Isaac Newton took center stage, his brilliance illuminating the path forward. But before we step onto Newton's stage, let us first sail back to 1632. Galileo, a beacon of insight, penned a remarkable work titled Dialogue Concerning the Two Chief World Systems. In his mid-60s, he had weathered storms of controversy for championing the heretical idea that Earth circled the sun. Seeking refuge in silence, he dedicated years to distilling his ideas on space and the cosmos into a book. In this tome, he mused about a boat, a simple vessel that would shape a profound theory. Imagine a sailor in a windowless cabin, observing plates, knives, and a goldfish bowl on a table. Along with a flurry of birds and butterflies, serenity reigns in the calm of a docked ship where the goldfish swims placidly and objects remain undisturbed. Yet, when the ship faces rough seas, chaos reigns. The cabin tosses and turns, spilling water and tossing objects. Galileo realized a truth in this turmoil. In the absence of a window to the outside world, the sailor couldn't differentiate between smooth, uniform motion and absolute stillness. Galileo concluded that there is no absolute concept of rest in space. Instead, all observers experience uniform motion in the same way. The essence of motion, Galileo declared, was relative. And so, the seeds of the first theory of relativity were sown. Picture the sailor once more, adrift on the seas near Earth's equator, swirling at breakneck speed around the planet, which itself orbits the sun, dancing through the Milky Way, propelled towards distant galaxies. Yet, this sailor perceives none of this grand cosmic journey. Millions of kilometers from their starting point, they feel nothing. A testament to Galileo's insight, the first steps into the realm of relativity. But Galileo's revelations met with resistance. The Church, a steadfast guardian of tradition, found his heliocentric beliefs heretical. His work was banned, suppressed for centuries. Yet, the tale of space's enigma continued, propelled forward by the luminaries of their time. Across the years, Isaac Newton and Gottfried Leibniz emerged, casting their shadows upon the cosmic canvas. Newton, born in England in 1642, mere years after Galileo's passing, stood as a titan of thought, his name synonymous with greatness. But an equally formidable mind, Leibniz, born in 1646, in what's now Germany, cast his own brilliance into the cosmos. Their rivalry ignited over the spark of calculus with accusations of intellectual theft. Yet, it was a question about a spinning bucket of water that encapsulated their cosmic battle. Newton, champion of absolute space, declared it as a rigid stage for motion to play out. In his view, even an empty universe would hold an absolute space. Imagine a bucket of water spinning. The water's surface curves, an enigma that Newton claimed was relative to absolute space. Leibniz, on the other hand, believed that space's very existence hinged on the presence of matter, rendering it meaningless in an empty universe. For him, space was a creation of relative positions. He questioned the essence of an empty cosmos and what purpose space could hold without objects to relate to. Newton's ideas held sway, becoming the foundation for nearly 2 centuries of scientific thought. The concept of absolute space and time was accepted, while Galileo's inkling of relative motion lingered. A universe governed by an unyielding metronome of time, a synchronized heartbeat echoing through every event. But the cosmos, like a starlit symphony, had more to reveal. The veil of certainty was about to be lifted, and the stage set for a revelation that would redefine the nature of space, time, and reality itself. Yet, to unveil this secret, we must embark on a journey, not with clocks and rulers, but with a primal force that flows through the cosmos: heat. In the distant reaches of the universe, encircling an aging black hole, rests our civilization, teetering on the precipice of its own demise. Sit and wait. They must, for in this dying universe, sitting and waiting is the sole card they hold. As stars flicker into darkness, raw energy takes on an unparalleled preciousness. The art of preservation becomes paramount. They've embraced a languid existence, slowing their very heartbeat to eke out every last spark of existence. Their existence is a delicate dance focused solely on survival. Their gaze, once vibrant, now rests on the ever-darkening skies. The relentless grip of total universal heat, death inches closer, a creeping shroud of entropy that blankets the cosmos. Time itself becomes their ultimate foe, an adversary against which all else pales. A cup of tea may tumble from a table, shattered on the floor, its pieces scattered, yet you shall never see that cup reassemble and leap back onto the table. It's an event foreign to our experience, a display that defies nature's order. Like space, time has long been a conundrum, its essence puzzling ancient thinkers. Aristotle deemed time a simple measure between before and after. Ancient Hindu philosophers envisioned a cyclical time frame, creation to destruction over eons. Still, the true nature of time remained elusive, an enigma shrouded in the shadows. Time, seemingly obvious, is a different beast entirely. Unlike space, it isn't a realm we can traverse at will. It carries a direction, a distinct past, and a looming future. Scientists often lean on pragmatism, relegating the nature of time to a mere tool in the experiment's arsenal. But in the pursuit of understanding, the question cannot be ignored. To unravel time's fabric, we must journey back to a time of horses and steam engines, the Industrial Revolution's dawn. Humanity grappled with a perplexing dilemma: how to gauge the efficiency of engines, particularly the newfound steam engines. Could the fiery energy of coal power machines as efficiently as draft animals like horses? This riddle gave birth to thermodynamics. Minds across minds wrestled with this quandary. Traditional animals were predictable. Feed them well and they worked. But machines, steam engines, were less straightforward. How much energy could a pile of coal unleash? The answer was critical, for replacing a horse with a steam engine needed to make economic sense. From this struggle emerged the foundation of thermodynamics. In those early days, steam engines eked out a meager 3% efficiency. Heat was squandered. Some seeped into the air. Some became screeching friction. Energy was lost as waste, an irrevocable truth embedded in thermodynamics. Entropy, a measure of disorder, was introduced to account for this inexorable increase in decay. Entropy, governed by probability, dictated the flow from order to disorder. Disorder, statistically, was far more likely than order. From this emerged a new understanding. Entropy's inexorable growth across the universe, the cosmos destined for a future of decay and disorder. Stars would fade, galaxies would dwindle, and the universe itself would become a shadow of its former self. Enter Lord Kelvin, whose 1862 insight grimly foresaw the universe's fate. Kelvin postulated that as energy dissipated, the universe would inexorably plunge into a state of universal rest and death. Finite and subject to existing laws, the cosmos would fade into oblivion. In 1867, James Clerk Maxwell, 19th century Scottish scientist, made his mark enlisting a demon to explore the depths of entropy. This thought experiment gave rise to debates spanning over 150 years. Maxwell's demon seemingly defied thermodynamic laws by separating warm gas into hot and cold parts. Did this challenge entropy's inviolability, or was energy expended? The debate continues to echo through time. As understanding deepened, a link between energy, entropy, and information began to crystallize. Information processing generates heat and the action of forgetting, irreversible calculations. So produces heat. The erosion of information, the act of forgetting, became essential for defining an arrow of time. Irreversibility fueled entropy's march. In the far reaches of time's tapestry, our civilization languishes, confronting universal heat death. The once vibrant stars have faded, and entropy looms. All useful energy spent, the universe a wasteland of disorder. But in this grim scenario, does time retain any meaning? A cascade of questions flows, leading us to our turning point. The bedrock of modern time and space lays the foundation, yet it's incomplete. As the narrative unfolds, a new order beckons, one that will unveil the universe's final days. In our quest, we'll journey beyond known boundaries into realms of new time and space, rewriting the story of existence itself. Deep within the impenetrable veil of their black hole haven, the remnants of a once great civilization resigned themselves to a fate sealed in cosmic obscurity. They drifted into a slumber, embracing a dreamless end. Yet, a handful of intrepid minds, fueled by their dwindling energies, clung to their curiosity about the enigma that was the universe. Ancient tomes, preserved across eons, whispered of the contorted fabric of space, the art of bending and curving reality itself. At the heart of these ancient texts lay the tale of light, the swiftness of its dance and the limits it imposed, unbreakable even by the most determined endeavors. A foundational limit that stood as the threshold to comprehending the profound workings of the cosmos. Imagine yourself under the heavens on a balmy summer night, gaze thrust toward the zenith, where the brightest star of the northern sky emerges. Vega, the celestial sentinel, a mere 26 years distant, yet a cosmic abyss away from the welcoming embrace of our transient existence. For we, ephemeral beings, shall never traverse the cosmic expanse to reunite with those cherished souls left behind on Earth. The swiftness of light remained an enigma. Early experiments, fleeting flashes, traversing the dark expanse, hinted at its boundless speed, far outstripping even the most agile echoes of sound. A puzzle unfolded. Was its speed infinite, stretching eternally beyond the grasp of comprehension? In the year 1676, Olli Roma, an inquisitive Danish astronomer, pierced the veil of uncertainty. His eyes were cast upon Jupiter's retinue of moons, their rhythmic waltz around the giant planet. His meticulous timing of their entrance into the gas giant's lunar shadow revealed a revelation. The celestial ballet was not a clockwork affair, a symphony out of sync. Roma's deductions painted a vivid truth. Light traveled distances with an ineffable swiftness, a speed surpassing 211,000 kilometers per second, now approaching our modern reckoning of 300,000 kilometers. This knowledge, however, merely scratched the surface of light's essence. A century of inquiry unveiled its intimate nature as intertwined with the very fabric of electromagnetism. As James Clerk Maxwell's revelations wove electricity and magnetism into a unified dance, so did light emerge, a self-propagating fusion of these forces. Maxwell's equations, though rich with insights, held a glaring void, a question unanswered. Relative to what was light's blistering speed measured. In the realm of the unseen, physicists embarked on a quest. Some envisioned an ethereal medium, an invisible ether suffusing the cosmos. Yet this notion introduced a new dilemma, a cosmic anchor of rest that threatened to shatter Galileo's cherished relativity. Amidst the explorers of this enigma strode a young prodigy named Albert Einstein. He questioned the very fabric of reality itself. Why, he pondered, did the flow of electricity or the dance of magnets not obey Galileo's decrees of relativity? Einstein's bold pronouncement echoed through the corridors of science. They shall not. From this seminal declaration bloomed the special theory of relativity, a radical manifesto proclaiming that all experiments held secrets yielding the same truths, whether conducted on a ship anchored in port or drifting serenely on a glassy sea. In this universe, a pitch of a ball and the measurement of light's velocity shared a common thread. The cosmic speed limit, held constant by the void of vacuum, was revealed. Yet, a peculiar truth unfurled. This constancy stood amidst the ever-shifting tides of space and time. The cosmic stage was no longer immutable. It bent, it flexed. Einstein beckoned to his fellow explorers. Space and time were no longer solitary entities. A union, a symphony of space-time, arose as the fabric of reality, immutable yet elastic, painting a new panorama of existence. In 1908, Hermann Minkowski, Einstein's former mentor, melded these concepts into a masterpiece of geometry, threading space and time into the very essence of existence. Space-time, the weave of the universe itself. Minkowski's vision illuminated the profound unity of the cosmos, unveiling an unseen tapestry beneath the palpable. This intricate dance of ideas cast shadows over Newtonian notions, and Einstein returned to the enigma that was gravity. In 1915, from the depths of contemplation emerged a revolutionary truth: mass and energy curving space and time, bending reality itself. The black holes, shrouded in mysteries, now unveiled their arcane dances, where the very fabric of reality bent and stretched, defying every intuition. Yet, this was but the dawn of revelation. From black holes sprang new vistas of possibility. Wormholes, warp drives, universes curved and folded, each thread woven from the malleable loom of space-time. The very universe stood inscribed in the calligraphy of gravity. As the stars danced their cosmic ballets, another revelation bloomed: the expansion of the universe, an unfurling canvas painted with time itself. It unraveled from a singularity, the Big Bang, birthing existence from nothingness. Galaxies drifted, like cosmic driftwood carried away by the currents of space, expanding at a relentless pace. Yet, in this cosmic symphony, a dissonance emerged. Conservation of energy faltered amidst the expanding tapestry. Amidst the crescendo of revelation, one enigma persisted, echoing the musings of Nobel laureate Steven Weinberg. How could space, empty and boundless, expand? A paradox, a revelation contradicting the very fabric of intuition. But in the realm of relativity, space was revealed as an ethereal void, neither substance nor structure, simply a canvas upon which the cosmic opera unfolded. Thus, as seconds, minutes, and hours danced through the veils of relativity, the cosmos remained an enigma, a mosaic of bending, stretching, and expanding space-time. The echoes of discovery and the silence of understanding blended into a symphony of curiosity. And still, as humanity's quest soared ever forward, the universe held its secrets close, revealing them only to those intrepid enough to embrace the boundless wonder. In the embrace of an enigmatic cosmos, a future civilization thrived, transcending the boundaries of conventional existence. Their realm was not bound by a singular notion of time, but rather a tapestry woven from the delicate threads of space-time itself. These masters of the cosmic domain harnessed the malleability of reality, wielding portals that defied the constraints of distance and time. These portals, great distortions in the fabric of space-time, allowed them to traverse their empire with an elegance that defied imagination. But in the midst of their expanse, a singular fascination beckoned them like a distant star. The concept of time. They recognized the uniqueness of their own temporal moment, isolated and unshared. Clocks were not uniform, ticking to their own rhythm depending on where they stood and what they pursued. Engineers reveled in the cosmos' secret dance, using the distortions near black holes to stretch time, allowing them to peer into the grand finale of existence itself. Their understanding of time was no mere illusion. For those like us who believe in the whispers of physics, the distinction between past, present, and future faded to a stubborn illusion. With Einstein's elegant equations of general relativity, they grappled with a newfound puzzle. The past, the present, the future, all inscribed in a fabric of space-time. Imagine, if you will, two electrons in cosmic flight converging in the celestial expanse. With identical charges, they repelled each other, their dance slowing as they approached. A symphony of forces compelled them to a halt, reversing their journey. This tale, though ordinary, was a key to the universe's secrets. In their exploration, they unearthed a baffling revelation. The fundamental forces of nature, electromagnetism and gravity, bore no allegiance to the arrow of time. Electromagnetic interactions, those threads that wove their existence, held no preference for the past or the future. It was as if the cosmos itself remained agnostic to the flow of time, a revelation that ignited their curiosity and perplexity. Yet, these revelations were the mere overture to the grand opera of time. As they delved into the realm of relativity, they unearthed an even more astounding discovery: the birth of the universe, a genesis of space and time, a singular event that marked the beginning of their cosmic journey. But this beginning was no ordinary inception. The newborn universe emerged with an unprecedented smoothness, a low entropy that set the stage for the dance of galaxies and stars. This smoothness bore a profound implication. The birth of their universe imparted an arrow of time. Entropy, the guiding force that dictated the evolution of matter and energy, surged from low to high as the universe unfolded. This transition, this change in entropy, imprinted upon their cosmos an arrow that pointed firmly from past to future. But questions loomed like stars in the night sky. The block universe, a construct of mathematical elegance, stretched infinitely in both past and future. Yet their universe, born from the enigma of the Big Bang, was not infinite in the past. Its birth was a moment of special significance, an event that defied mathematical continuity. How did their universe emerge from this singularity? What cosmic forces birthed their space and time? In the midst of their contemplation, the universe's birth echoed with whispers of another mystery, the concept of entropy. Why did their universe emerge with such low entropy, enabling the orchestration of galaxies and stars? The answers remained elusive, and the cascade of questions seemed endless, but their quest pressed on, driven by an innate yearning to uncover the very essence of existence. The possibility of time travel lingered in the equations of relativity, a tantalizing possibility that beckoned them beyond the realms of the imaginable. Could space and time truly curve back upon themselves, forging paths to the past or shortcuts to the future? As their voyage through time unfolded, brilliant minds arose and left their indelible marks upon the tapestry of knowledge. Van Stockham, a Dutch volunteer, gazed upon the mathematics of rotating universes, and in those equations he glimpsed the potential for time loops and temporal exploration. His path, tragically cut short by the chaos of war, paved the way for a brilliant eccentric named Gödel. In the heart of the Princeton sanctuary, Gödel and Einstein forged a friendship that bridged the realms of mathematics and physics. In 1949, Gödel's gift to Einstein unveiled the possibility of rotating universes and closed time. Like curves, the very fabric of space and time seemed to bend and twist, offering the tantalizing prospect of traversing through time itself. The echoes of these revelations reverberated through the corridors of science, setting off a cascade of exploration into the enigmatic nature of time and space. The grand stage was set, and the mysteries deepened with every revelation. But amidst the crescendo of discovery, one question remained. Would these theoretical constructs ever find form in the tangible universe? Could the very essence of time travel and the manipulation of space-time be harnessed? As the future civilization delved deeper into the cosmos, their journey through time continued, and the unknown beckoned them forward, like stars in the boundless night sky. Far in the unfathomable future, a once mighty civilization clung to existence in the dying embers of the cosmos. Stars had fizzled out, leaving matter to melt in the cold abyss. Life, nearly extinct, struggled for its last breath. Only a handful remained, resilient yet fragile, straining to witness the dwindling bursts of cosmic brilliance. Millennia of prophecy had foretold this cataclysmic era, an epoch where even black holes surrendered to the relentless march of time. Desperation blanketed their existence. A fading ember of hope flickered in their hearts as they beheld the cosmic elegy unfolding in the skies. Ancient texts had forewarned of this inevitable demise, cautioning that not even the steadfast grasp of black holes could withstand eternity's erosion. The grand interplay of relativity's gravitational dance, though potent, yielded to the inexorable decay dictated by the microscopic quantum realm. With a weary persistence, these last remnants had struggled to bridge the chasm between the quantum and gravitational domains. An arduous endeavor that had occupied eons, driven by an insatiable quest to unify the two pillars of physics. Stars, galaxies, and cosmic realms had once been their dominion, a testament to their mastery of the macroscopic realm. Yet the tiniest particles and their elusive dances had eluded their comprehension, igniting a cosmic journey to merge the infinitesimal and the colossal. The cosmos resounded with tantalizing questions, resonating from the primordial echoes to the present. What threads wove the fabric of existence? How did the symphony of space-time harmonize with the frenetic ballet of subatomic particles? Amidst the enigmatic echoes of the past, a lone figure emerged from obscurity to illuminate the path of understanding. The name etched in stone, Paul Adrien Maurice Dirac, stood as an epitaph to brilliance. Born in the early 20th century, his journey began humbly, shunning social conventions and immersing himself in the mystique of science. Silent conversations, solitary wanderings, and introspective contemplation were the hallmarks of Dirac's genius. The quietude of his demeanor belied the turbulence of thoughts that raged within his mind as he traversed the intricate landscapes of quantum mechanics. The storm of quantum theories clashed against the rocky shores of Einstein's realm, presenting Dirac with an intellectual Everest to scale. The equations of Schrödinger and Heisenberg, though powerful, lacked a harmonious resonance with the fluid curvature of Einstein's space. Time. Armed with a relentless will, Dirac embarked on a relentless odyssey to meld the two opposing universes. Like an alchemist of the mind, Dirac transmuted mathematical symbols into profound revelations. On a December night in 1927, amidst silent contemplation and tireless calculations, he unveiled the mathematical offspring of relativity and quantum mechanics. A dance of symbols and equations bore fruit in a relativistic quantum equation, a formula that whispered secrets of electrons and the cosmos. Within the embrace of this equation, the electron shed its enigmatic veils. Its spins and magnetic behaviors, once cryptic, now flowed naturally from the folds of Dirac's creation. Yet, amidst the mathematical tapestry, a paradox materialized. A dual nature emerged, revealing not only the electron, but also its antimatter counterpart, the positron, the causitron. The cosmos unveiled its antimatter tapestry, a mirror image universe hidden within the folds of space. Time. With Dirac's equation, quantum field theory emerged, an edifice that underpinned the symphony of particles and forces. The elegant dance of quarks, leptons and bosons unfolded, choreographed by the harmonious symphony of Einstein's special relativity and quantum mechanics. But the gravitational arena, carved by the curvature of space-time in Einstein's general relativity, remained the final frontier. The yearning to merge gravity and quantum mechanics birthed theories that promised unity. Yet the gap persisted. String theory, M theory, and loop quantum gravity painted vibrant landscapes of multi-dimensional universes and interwoven threads of reality. Yet, within the fabric of these theories, space and time remained elusive phantoms, their fundamental nature shrouded in enigma. As the civilization journeyed on, casting its gaze towards the horizon of existence, the limits of space and time beckoned. The cosmic twilight loomed, a grand finale that echoed across the eons. As black holes surrendered to decay, a final darkness descended, extinguishing even the last vestiges of existence. Through these final moments, the universe whispered its last breaths, a haunting reminder of the impermanence of all things. It was a poignant symphony, a cosmic swan song, leaving only echoes in the annals of time. And so the journey drew to a close, a narrative woven from the tapestry of space and time. It was a saga that spanned eras, uniting cosmic splendor and microscopic intricacies. The quest to understand the universe's deepest mysteries had cast light into the abyss, uncovering realms unknown and leaving questions unanswered. In the grandeur of the universe's twilight, as the cosmic fire dwindled to embers, the civilization took its final bow. Yet, within the echoes of silence, a whisper lingered. The universe's secrets might forever remain, shrouded in the enigma of space and time. The cosmos, ever enigmatic, preserved its mysteries, inviting future seekers to continue the timeless quest for understanding.